So you must be thinking, how dare this foolish YouTube boy talk about such a complex field like physics? He is a bloody YouTuber. You don't need any physics degree to do YouTube. Well, to those people, I say, you are correct. However, I can make this video because at a very young age, a doctor told me I was a genius. And so I know quite a lot about physics because I'm a genius. Unfortunately, the lovely thing about YouTube is that no one can really stop Albert from doing it. Not like in school, where he had his head dipped into the toilet just for thinking he was smart. Which reminds me, fuck you, Kenny. I'm coming for you. You messed up big time. Right, so now that we know that I'm well overqualified to do this video, let's crack on, shall we, you bastards? I'm sorry, I shouldn't have called you that. Please don't unsubscribe. From quarks to the cosmic web, physics is broadly the study of nature, matter, and energy. So a nice way to kick things off is by looking at the four fundamental forces that govern our universe. These are the strong one, the weak one, the electromagnetic one, and the gravity one. And don't really know why I left that in the video. So now that you know all about the fundamental forces of physics, now we can actually move on to breaking down physics into three main branches. The first branch being classical physics, the second being quantum mechanics, and the third being relativity. We should really start with classical physics, as it's technically the first branch. But fuck it, Albert is a rebel, so we'll start with quantum mechanics first, as it's always good to start small. Microscopic, in fact, and that's coming from the atoms. So let's start with this thing called the Standard Model, which is the closest thing we've gotten so far to the theory of everything. There are 6 quarks: up, down, top, bottom, charm, and strange. And these little guys are basically responsible for making up particles known as hadrons, which includes everyone's favourites, the proton and the neutron. Oh, and quarks only hang out in groups because they are too afraid to hang out by themselves. Right, so next we have the leptons, who are basically like the quarks, but don't like to feel the strong force, and are not shy to hang out by themselves. A bit like me, but that's because I don't really have many friends. Next we have the gauge bosons, which are basically the boomerangs that the fundamental forces play with, apart from gravity, who is currently too broke and can't really afford a boomerang. So now that we're done with the less interesting bosons, we can now move on to the more interesting bosons. The Great Higgs Boson. The existence of the boson was predicted and worked on originally by Mr. Singh's best mate, Homer, all the way back in 1998 during an episode of The Simpsons. Although 14 years later, Professor Higgs, oh shit, wrong guy. So Professor Higgs claimed he did all the work to find the Higgs boson, and in 2012 he made it public that he was the one who discovered it. Now, I don't know about you, but when I add 2 and 2 together, I can clearly see that he stole all of Homer's great work. Ah, Professor, if only you knew 2 plus 2 was 4 and minus 1 is 3, then maybe you wouldn't have got caught by Albert's exceptional detective skills. So, the discovery of the Higgs boson has really helped with our understanding of mass. And now that we know all about the Standard Model, it's time for us to move on to atomic theory. The concept started way back in ancient Greece and tells us a good old story about how the atom looks right now. The word atom comes from an ancient Greek adjective meaning indivisible, but that's been outdated now, as we know that atoms are in fact made of elementary particles, and in a few hundred years' time the elementary will probably no longer be elementary, and everything you learned in school were a bunch of lies. So, other interesting facts in atomic theory include the fact that electrons now exist in energy levels and pretty much get excited at every other electron they see, and bully other electrons that they don't really like, which is quite unfortunate for me. Also, certain electrons pose before bros, and yeah, they pretty much get excited and leave the atom when a hot piece of radiation comes along with a very high frequency. Yeah. And another sub-branch in physics is nuclear physics, which mainly involves fission, fusion, and the fact that we can't really predict a nucleus behaviour because it's just a bit random. But nonetheless, an object's radioactivity can be mathematically shown by calculating the differential of the number of unstable nuclei present in that object with respect to time, or simply this. I also thought that it'd be a good idea to mention the fact that there's an exponential relationship between the initial number of nuclei in an object and time. And finally, in honour of this channel's theme, I thought it'd be a good idea to talk about a bit of E equals mc squared, which was of course granted to Einstein by Finestein in one of his dreams. So one of the implications of this equation basically means that nucleons weigh more outside the atom than inside it, because the energy that's used to separate them from the nucleus is kind of used to just create more mass. Which is kind of a bit strange because as humans we're always trying to get rid of that mass by using our energy to work out, run, etc, etc. And also I'm just trying to drag this video a little bit just to the 7-minute mark so that my voice perfectly aligns with the music when you know, the video is done, giving a little dramatic effect and creating the illusion that I actually put effort into this video. So yeah, just gonna wait a little bit, and yeah, so what I'm trying to say is that it's a bit odd that these nucleons try to put on weight rather than lose it. Very odd behaviour, that. So if you made it to the end, well done. I personally would have shot myself rather than watch this, but as you can clearly see, I still have 2 more branches to cover, so be on the lookout for that. Might be out anywhere in the range of 6 months to a few years, and I'm happy that you made it this far through the video, so thank you.